Alright, so we're gonna start from scratch again, I think. And the reason for that is, and I've done this in the past, but I think it's actually kind of nice sometimes to just, when you're learning something new, just always start over. Because then you're like, okay, what were we doing? You have to remember the whole thing, and it's like, I don't know, it's nice. Okay, so the PCB that we're building, so it's going to be this full thing, but we're going to start off with this. And so the first thing that we're going to do is we're going to add a 555. So this is a through hole, right? So we want the... Why are these changing on me? What the hell? Okay, so what's the difference between this and this one? NA555 Anyways, this is the one. Okay. See, do you see how these are changing? That was weird. Alright, so we... Special symbol for telling ERC where power comes from. I don't really know. Ugh. Oh no. I don't know. So, so I'm pretty sure that... Doesn't this get tied to 5 volts? So let's try to remember... D means SOIC, I guess. Okay, that's not useful. So, does he show the final circuit diagram? Okay, and then I'm actually going to change it. I realized, like, for my first thing, I want, like, a resistor. And I actually want to do not 0603, but 0805. I don't think I'm going to be short on... We're even going to do the hand solder. We're going to just make nicer traces for it. I think we only need 2 resistors, actually. And then here we want, but we're gonna, no. We need, well, we need 2 resistors. And we'll go through, okay. We'll go through this thing again. So let's make this 1K. We're gonna make this other one 1K. Then we're gonna add a capacitor. And we're gonna use just pure capacitors. Okay, so the output though, the output is the weirdest thing there. Okay, so pin 2 and pin 6. Actually, you know what? Can we try to do the label thing? Do I do this? L? There's that, but then I think I want a G, right? Place global label. So this is going to be 2, 6. I don't know. I don't really know how to. But my guess is that I can do this. And then I can, this capacitor is grounded. And then similarly, we are going to have, we're going to need a potentiometer, right? Is it like this? Now we're going to have to figure out all the footprints and everything because, you know, I was kind of struggling to figure out whether or not I wanted to try to just not do this as a standalone device, but make it like a Eurorack module. But then I was like, I don't really want to do that because then I have to design a PC, a power supply unit thing. So I feel like I just want to start easy. Okay, so this, this will be like this. Can you do that? Wait, what if we grab this? Okay, so now we have that. I feel like this is much cleaner. What is that? I don't know what that is. Oh, that's cool. It highlights the net. That's nice. I didn't know about that. Tilde is powerful. Okay, so then this junction is going to be and then we just need this. So I feel like that's it. But then what we need is we need to figure out the value of the I think they call it a decoupling capacitor. Okay, so let's look up if that's the right thing. Is used to stabilize power supply voltages and filter out noise. Okay, yeah. Even the output voltage gets decoupled. Okay, so what we're going to do then is we're going to do this, and then we're going to add a capacitor. And we need to get all the values here, but, you know, oops. Oh, because it's selected. Okay, so there's the decoupling. So now we need the output logic, right? So Q is our output. What else do we have here? 5. I forget what we need to do with 5. We need to go watch the video. Okay, so before any of this, that we're going to make... This is going to be a Q. This is a no connect. This capacitor is the decoupling. This one, 1UF. Or do we just do 1U? Resistors, caps. What is the standard way? Do I put 1UF or, you know, whatever? Okay, so we want to put UF, 1UF. Okay, so the whole unit is there. So, but then what about this? For 1K, we don't? Okay. I just feel like there's some strange conventions, you know? Okay. But then don't they know that a capacitor is in farads? Anyways, so we have that. Now we just need to figure out how much the decoupling is. I forget when he does that. And then we're also going to do... Oh wait, we need a LED. And then I forget if you're supposed to do resist. You're supposed to do the resistor after. What? Okay, and then here, this is going to go to a headphone jack. But the unfortunate thing about the headphone jack is that while they have a TS jack, see how they're changing? That is so annoying. I think it's just this. While they have this, And I guess they have a footprint for it. I don't know. You can't really get these. If you look on LCSC, you can't really get these. The only ones they have are like stuff like this, which is a TRS. But even this, like, I couldn't even find this. There was all sorts of weird ones. Maybe that. I don't really remember, but that's one of those ones that we need to import. So we need to go back and find the TRS jack. And why an audio jack for my output? I just couldn't think of anything else. I don't want to use like a weird terminal block or a header, even just like pin headers. I don't want to do that. I want to have something I can plug it into. So let's delete that. Okay, so let's get this capacitor, or this capacitor's the decoupling's value. And then we need to do the pin 5 and the pin 4. And I need to actually delete this because I don't think that is right. I don't remember what the recommendation is. So let's see, where is he? Okay, so he's just explaining it. And we've gone over it a bunch of times, how it works. So we're sort of past the stage of like figuring out how it works because I know how it works. One thing that I guess I should add here is okay, I guess I'd like to go find the data sheet myself. Find data sheet and do the frequency calculation. So we're gonna go do that, but all right, so he's doing the timing. Now he's explaining the thing about the power supply. So pin 7, what is pin, wait, is that pin 7 or pin 8? That's pin 8. This is pin 7. Yeah, we have that. Pin 7 is connected to the discharge thing. It's connected to this. Okay, good.
This is happening is, our power supply is over here and we've got all this, but we're overshooting a range. You see, there's what you see is that nice transition from 0 volts to 5 volts is maybe not so nice. There's a lot of junk in there. So if we add this capacitor that they're recommending from ground to pin 5, boom, clears it right up. So definitely recommend that. Point. So what is it talking?
He said it.
What you see is that a lot of ground to pin 5, boom, clears it right up. So definitely recommend that. 0.01 microfarad capacitor.
So this is just going to be a cap to ground. So we can just do this. And then he's going to add the decoupling too. I think the decoupling is 1 microfarad. No, it's not. It's like 0.1 microfarad. Okay, so we're almost done. We just need to do pin 4.
We're going from pin 5 to ground. There's still some other noise if we go in even further. Go into, oh, I'm going the wrong way. Go all the way into nanosecond range. You see there's some overshooting here. And what's happening is when the output wants to turn on, when they switch, there's a different current requirement. So they're pulling more current, or they want to pull more current from the power supply, and they're not able to pull that current as quickly as they would like to. And then at this point, they end up getting more current than they wanted, and it kind of overshoots. And I'm sorry we don't see more sort of back and forth oscillations here. That's fairly typical, but it looks like it levels out pretty quickly here. But we're overshooting above, right here. This is 5 volts. We're between 0 and 5 volts, and we're feeding into something that's expecting 5 volts, and we give it 6 volts. That could be a problem. And the reason that this is happening is, our power supply is over here, and we've got all this wire flow right through. We're not as an inductors. And that magnetic field is going to resist a bit of this by short a lot, going on pretty quickly. From here, it's. But of course, we don't want to have a extension cord run all the way up. So we're back to that crazy overshoot. The other thing we can do is if we put a capacitor just across our power connection here, that capacitor can sort of get charged, and then when this chip wants to pull more current, it can pull it from the capacitor. So if we just take this is a 0.1 microfarad capacitor and just stick it right across those power pins.
Okay. So, where's the sign footprints? Okay, so we're not quite done because we need to do pin 4.
Boom. We get basically the same thing. And that's because, the power supply has capacitors in it. It's doing essentially the same thing that we're doing with this capacitor here. Chip and put it right across the power pins on the chip. And if you look in any electronics, every chip is going to have a capacitor or maybe multiple capacitors sitting right next to it to smooth out these current transitions. I'm not going to get too crazy with it. I think with this computer we're building, we're not running at a super high speed, so if it takes a little while to come up and stabilize, it's not too big a deal. So what I'm going to do is just put one of these little 0.1 microfarad capacitors on each breadboard capacitor here to pin. And so I'm going to. And we've also got a 0.1 microfarad capacitor just sitting across our power pins. And so I'm going to move that over here just so it's a little bit more out of the way, but it's still connected to the board across the power pins, which I think is good enough. There's one other thing that the datasheet recommends, which is pin 4, which we don't have anything connected to. And I didn't draw it on the diagram here, but what pin 4 is it kind of gives you this other connection here to the reset of the latch. So it gives you kind of a direct connection in here to just reset this latch if you wanted to. And actually, I should draw it, it's inverted input. It's not hooked up exactly like this, but this is basically how it functions, is if you bring pin 4 low, it'll just force this latch to reset. It overrides anything that's going on over here. So normally we wouldn't want to bring that low unless we wanted to reset this. And so what the datasheet recommends doing is to prevent it from accidentally going low if there's some stray voltage or something. It recommends, if you're not using it, to just tie it to 5 volts. So if we just connect that to 5 volts.
Okay. All right, nice. This looks pretty good. So this isn't the worst schematic. This is better than the other one. So 5 volts flows into the discharge. But it also is going to flow through the 1K and in series with the 1M potentiometer, and it's going to fill up this capacitor. But it's also connected to both of these, which are the comparators. I always forget which one's the threshold and which one's the trigger. I'm guessing trigger is the
then
yeah, trigger is the bottom one because trigger is to trigger the set of the SR latch. Okay, so now we just need to we did pin 4, we did the decoupling capacitor. Now we just need to find that jack again, and the annoying thing here is how to get That one seems pretty good. Because the other one only has like 18 stars, right? I think this is what I... Oh, wait. He should add a note of why that one was this deprecated. Let's just try this. Do we do it inside the Python that comes bundled with KiCad or not? Does that matter though? If the pin numbers are switched? Why don't we try it? What is this guy up to? I always like to see. The sad thing of these are the Adapile guys. That's cool. Okay, so let's just try it. What's the big deal? But I kind of want to all right, let's read it because I just want to know where it's going to put the files. Like I don't want to pip install into a global environment. That's like the worst thing to do. Screw it. Let's just do it. Let's just do it. So, we're gonna pip install this thing. I don't have pip. That was by design, though. Let's see, what is that? UV tool. Install commands provided by a Python package. What does that mean? Let's look this up. What is UVX? Wait, what's going on? It probably means like UV execute. Okay, yes. See, it's just yeah. UVX is just an alias to UV tool run. That makes sense. Is this gonna do a pip thing though? I'm wondering, like, where does this pull from? If a tool is used often, it is useful to install it to a persistent environment and add it to path instead of invoking UVX repeatedly. UV tool install rough. Right. See, that's good though. Reducing interactions. That's exactly what I'm. So I want to do UV tool install easy EDA to KiCad. So let's just try that. UV tool install this. Now I should be able to do easy EDA to KiCad. Bro, that's what I'm talking about. These people at Astral, dude, they just build such great stuff. It's just so nice to use, you know? All right, so let's try this. But we want to get our so wait, what's the first thing that we should get? Let's get the potentiometer. So I'm actually going to open up the old project just to get that. I think we can actually figure it out. I think it's called RK901 or something. I forget. I think it's actually in. Where is my? Oh, you know what? It's called. It's in Eurorack. I need to clean this up. I didn't put the documentation for that. Oh, okay. The standard potentiometer is from. Is this the right one though? I think it is. RK09. Shit. Let's do this. Alps, Alpine. They probably have this RK. What? Can I just do RK09? There we go. So I forget what we had before, but it's something like this. Yeah, so there's that one. Okay, so we'll need to look through these because I think we need to get the specific one. So I feel like this is the hardest part. So just saying RKO9. Ooh. So RKO9 is not sufficient. This is where it really gets into this like kind of tricky thing. But actually, what are just the most popular? So these are the most popular because they're like totally. There's probably even surface mount. Yeah, these are surface mount. Not that we don't. And then you have like trimmers. And more of these. I don't know what that is. More of that. Yeah, trimmers seem to be very popular. Because the alternative, instead of having the sort of stuff in the front, we could just have it on the top. Which I think might honestly make more sense. Because and I think yeah, oh, we did have the toggle. So instead of this though, oh yeah, empower. Actually, power is what we forgot. Right. Okay, so find the jack, find the pot, the barrel, the LED. Yeah, it's all the part sourcing that makes this really hard. What else do we need? We need the switch, the selector for the second. Okay, so well, the headphone jack we know though. I'm almost positive I know what to do there. So let's, instead of, because the thing about the the headphone jack is actually going to be kind of tricky too. Yeah, man, the design of the PCB itself and just the physical stuff, not the schematic, but the PCB is much harder because I thought I could click on this thing. Oh yeah, I can. Audio amplifiers. What are they called? Audio amplifiers, current sense, FET, linear, op amps, sample hold, video amplifiers, comparators, diff amps. Yeah, all of that is just oh, here we go. Connectors. I think it's just in audio connectors. So if we there's with this one. So this one's SMD. So I'm fine with an SMD. The only thing is that it's gonna complicate the design a little bit. So maybe we'll have like the front face will have the actual connections, so power and the headphone stuff, but then the button, the LED, all that will be faced upwards, and the knob and the switch. So I'm wondering if we can actually maybe change the because like that looks pretty good to me. But the question is we just need to do a lot of matching. You know what I mean? Like, God, I hate these drawings, dude. These drawings are so hard to read. Okay, so this is the pin. What is this? 0.4. Wow, that's very small. So if we did this, okay, let me just draw that out. So, oh, and interestingly, seems like it has a A surface mount thing. So wait, what? Can we see the footprint? Yeah, that's wild. I guess it has 2 symbols for it. Or are these all ground? I can't even figure that out. Okay, so when this thing slides over, 2 touches 2 and then 3 touches 3. All right, so that sounds good to me. But now we have the PCB, and then above this we have 0.4 millimeters. So now what we want is a button. Okay, so I'm just gonna make a link to this. So this is gonna be the this is the slide switch, height 0.4 millimeters, PCB to, so all right, so that's that. Now let's look at buttons. Oh, I guess there's, yeah, the push button switches. No, but that's actually, you know, maybe we could use that. So in options, we can either use a slide switch. So we okay, so push button. Okay, but what we're looking for is, I think, called moment. I'm almost positive it's called momentary. Wait, where were we? We don't have that. What is toggle? Oh, okay. Yeah, toggle works too. It might be called tactile. Let's go through all of the things called buttons. Push button switch. That, I don't think that's right. I'm just gonna actually. Okay, so push button. So some of these. Okay, so latching. So we don't want latching. Let's see, non-latching. So if we apply this. This is weird, man. I feel like I'm just in the wrong spot. Because if you look up just like. Locking, latching. It's so weird. What if I just look up momentary button? Yeah, stuff like this. What is this categorized under? Single pull, single throw. Maybe it's under. It's got to be under tactile then. Yeah. So I'm down with a I'm down with something like this. This actually seems pretty okay. And I have these, but I mean, not that that matters. I'm still gonna order. Well, I don't know if I'm gonna order it or not, but I would kind of like to SMT. This is through hole. Through hole is definitely gonna be stronger, but the whole point of this project is really to test out how good SMT can be. So I think I want to go with this. Let's just look at the dimensions of this one. Interesting. think this might work. So this button. So we could use oh wait, how do I? There we go. Tactile button for single step mode. But then the height of this thing, I think, is 9.5 millimeters. So it will stick out. Switch height. I don't know if that's the total. I don't know if that's like, because this drawing is not clear, right? Like, oh, H. So H. Oh, right. Okay, here we go. O 1002S 095. Okay, that's the height, 9.5 millimeters. Okay, so the total height is 9.5 millimeters. So the switch will be like 5 millimeters. PCB to full top 9.5 millimeters. Okay, I'm down to use that button. So we have a lead on the switch. I'm not sure what I'll like more. The slide switch or the push button switch. But so we have at least the tactile button. We have that, and it's SMD. Now let's figure out the LED. RGB LEDs. Probably this, right? Okay, so I forgot I might need 3 LEDs. What's the difference between so there's like toggle, push button, and slide. And then there's also the toggle is the angled one. I'd prefer a push button over that. I'd prefer a push button or slide over that. So no to the push button, or no to the tactile, or wait, no to the toggle. Okay. So you got the barrel, the power, and then the headphone jack. Barrel jacks, potentiometers. Push button, slide switches, and TRS jacks often come in panel mount or front mount variants. So if we go back to here, let's see what we have here. Ooh, let's see something with 10 million cycles. Let's see how much that costs. Damn. Wait, no, that's not right. Still, that's pretty nuts that this button is rated for 10 million cycles. That's pretty crazy. That's nuts, man. Okay, so in the case where I can't find all equal height parts, then some need to have a harness and panel. What? I feel like they're cracking down on limits. Okay. Let's see, do they have a vertical thing? Yeah, no way. Okay, let's just go with it. I mean, I'm trying to, like, do too much. So if we copy this, and we do easy EDA to KiCad, I think -- full, let's just go check. Full LCSC ID, like that. And then when equals. Nice, and it came with a step file. Okay, so that's good. So what I want to do now is this is just going to be my house, my home. But is this already going to be in my symbol library? That's kind of what I'm wondering. So I'm going to look up PJ. Let's just copy that. Let's try to add that. Oh, hot damn. Oh, wait, no, wait. That's not right. Where is my lib? That's not what I want. That's not it. Because that's from a different place. But I'm wondering, can I just add this file, import? How do I add a library? Add the environment variables. Wait, how do you do environment variables? Oh shit. Oh, here we go. Easy EDA to KiCad. And then okay, but is that it? Okay, now preferences manage symbol libraries. Preferences manage symbol libraries. Add the global library. Oh wait, that's the wrong one. Did it work? Oh, it did. Okay. All right, so now if I add and I look up, what is my part called? Hell yeah. Okay, so we got our workflow now. That's good. And this should already have its footprint, right? Cool. Oh, you know what we needed to do though? We also need to do height matching even on this part. Presumably, actually this might be kind of tough because oh my gosh, what am I looking at here? Okay, so our height is wait, I can't tell. What am I looking at here? It seems like it's 5.2 tall, which is a problem. Wow. You know, the things that you think of. Oh wait, I didn't get all of it. Let's see, am I actually out? Oh, you know what? But we have a step file, actually. You know what? That's an interesting idea. Let's see if I can import documents, KiCad, Easy EDA, 3D shapes. Okay, so from here to here, parallel disk 4.6. But what are these buttons? Is this gonna... Those are like... What are these buttons? Okay, so that's 5.2. I don't know what those buttons are. Those little knobs. Okay, but this is for... So the jack has a 4.6. We're going to ignore those little dots at the bottom. Height. Okay, so we have 4.6 millimeter height. So wait, but the slide switch... let's see, let's do the same thing for the slide switch. Now that we have the workflow, did I lose it? So we're gonna copy this, then we're gonna do the same thing here. Oops. Oh, hell yeah, dude. I only want to do stuff that has the step file. That's so sweet, man. Because this makes it so easy, then we can just import all of these things and look at them in a normal CAD. Okay, so here we're going to be looking at the distance between here and here, which is 2.6. Wait, where did I get... What? Wait, right angle. I think that I'm not able to use this thing then. I might not be able to use this. I don't know. Maybe I'll still use this. So the switch that I have right now is 2.6 millimeters. And it's SMD. So that's fine. It even has the travel in here. You could even index off of this face in here and say, okay, the travel is 0.7. And presumably their data sheet actually shows that. Oh, the travel. But I think that if that's probably okay, so I don't know. The travel seems like it's 0.7, but dude, that's so sick, man. Look at this beautiful CAD model. It's such a tiny part too. All right, so the barrel, This is going to be so Frankensteinish, but okay, so I think we're just going to go with it. I think we're going to use that switch, that jack, the button. We need to go back to find the button that I want. I want to use this button. I guess I don't want to use this button. That is like the iconic. This is the iconic button, man. I do kind of want a surface mount version though. There we go. That's like, there we go. Let's look at that thing. Wow, what a nice drawing. So H is based off of their part, yeah. So they typically do this where they parameterize it, because even in this, you know, their designs are modular because there's a lot of different needs. So this is 7.5. But they probably do have a tall version, right? Well, let's just, okay, first, let's try this. Okay. So the button that I have right now said, what, 7.5? Okay, so we have the button, the jack, and actually, wait, did I close this? Okay, so, and then, they don't, oh, this, okay, this is, so it's 3.5. So, I think I would like a taller version. But presumably they have a taller version. The switch height, we want it to be, so the switch height, that's an interesting question, because how they do switch height, for a tactile momentary switch, does switch height typically refer to the distance from the bottom of the part to the top of the switch. It must be. That's the only thing that makes sense. Anything else would be kind of confusing. So in that case, yeah, the PCB seating plane. Okay, good. So, okay, so here, I think we probably want our minimum, like let's say that right now the jack is at 4.6. So let's say that the housing is 5 millimeters. So we have the PCB. Then we have like parts. So then let's say that the top panel is 2 millimeters. Then we need a button height of at least, I mean, we need to take into account the travel, but let's say this is 1 millimeter above, assuming that it's not going to travel a whole millimeter. Then we want our switch height to have a minimum height of 5 plus 2 is 7 plus 1 is 8. Did we already do this one? The question is whether or not it has a 3D model. Okay, good. Let's see what its travel is. Yeah, so like Okay, so now we need to find our power connector, our barrel power connector. Connectors, DC power connectors. Honestly, it might be easiest to do bro, I want to do something with pogo pins so bad. Not on my first PCB, but I really like those. So these IDC connectors, this is what Eurorack is standardized on, is the IDC. Let's see, how much is a USB-C? Because this might be how I want to do it. Dude, it's like 5 cents for a USB. That's crazy, man. This is a female. That's wild. All of these will be don't connect, but I feel like I just want to do this. Cause let's just out of curiosity, right? Like, how is that even surface mount? That doesn't really look like surface mount. Wait a minute. Oh, it's surface mounts with that? Oh, that's too small. I can't do that. That's too small. Out of curiosity, I want to So the main thing would be soldering that. Sounds like a nightmare. Well, out of curiosity, let's get a It doesn't really matter. I mean, I know I could probably just look at the drawings, but I'm just so much more comfortable with Onshape. See, that's a lot more reasonable. So, okay, so that was actually pretty fun because clearly, but I wonder if I can get like a power only. Micro B, micro A. What is it? Micro AB. Type A is the like MIDI type, right? No, no. Oh yeah, that's what I'm talking about. We could do that. I don't know if I really want to do that though. I think we should do what it's been designed for, which is just standard DC power connectors. The only thing that's crazy is that there's like, for instance, this one. This is just the most. I think this is the most popular one on here. DC05 A200. It's a through-hole power connector. It's just got 3 pins. What are the pins? What is that? Or it seems like 2 is the sleeve, and when it's when something's in there, then 3 is connected to 2, and then 1 is the tip, which will go to 5 volt. Oh, it did, okay. So it's the other way around, I guess. Anyways, pin 3, we can just make a no connect, right? When no plug is inserted. So the idea is with this symbol is that when you put it in, this stretches out and pushes away from the thing. Okay. Alright, so I'm down to try that one. But I think that wasn't there a problem with this thing? I need to look at the 3D model. It's so hard to Did I copy it? I don't know if I copied it. I am loving this tool. DC in. .04. What did they say? .11. Okay. But the... Okay. .2 millimeters, 6.4 millimeters. So, wait, when we go to this thing, that's 6.4 in diameter. And then this is 2. Oh, okay, cool. Okay, then this attaches to there. So this is pin 1. So this is the sleeve. And then it breaks. I wonder if we can get a section view. Here's what we're gonna do. Okay, we're gonna do section view. Okay, so then when this gets depressed, pin 3 no longer makes contact with pin 2. Okay, I think we can just use that and we'll make it work with whatever it is. But the only thing is that the barrel is 11 millimeters high and like kind of like 10.4 if you like exclude the little lip on it, because you could maybe do that. But I think realistically you just want to go with 11. But see, that changes the whole thing, though. That's why this is so annoying. Is something 11 millimeters high. Now we have to change the button because the button is going to be too short. The LED. I wonder if we could get one on its side. See, that one seems kind of nice. But they don't have... Yeah, they don't have their height. This one doesn't have fucking anything. What the hell? Or is that just because I didn't do it right? These drawings are so bad. It's honestly easier to go through this whole process of... I mean, I don't know. I feel like I'm just getting hung up on nonsense. Because if we go back to... I wish we had stored the links, but I think we just need to look for the button. If I do this, does it... Oh, it does. It's not smart enough to know. Alright, that's a little unfortunate. Which ones are we missing? We have audio, the DC and the key. I don't think we have this one. Switch SMD. So if that's the case, if instead this is not 5, but it goes to 11, so then we have 11 plus 2, 13 is, 14 is our minimum. So we just need to go to tactile switches, minimum height, $14. That seems good. Just look at the circuit. Uh-oh. Okay. But this is through hole. That's fine. I don't really care. Because they're so tall, I kind of expect most of them to be through hole. Ooh, that one looks pretty good. I like that. Nice. Let's do that one. No without bracket, 50 milliamps. 6 millimeters, 300,000 cycles. Does this have the travel on it? I would expect the travel to be yeah, I mean it's a pretty standard, because the thing is it's all in the housing, so it's like that's so sick. Okay, so now we're gonna use a tactile that's 14. Okay, so then we can put the barrel on the PCB. All right, so now we need to get the potentiometer. Now the potentiometer, I don't know, do they have horizontal buttons? Maybe we should just try to do that. This is a totally different style because it's like very constraint based. Let's look at some of these right angle ones. This is surface mount. This is surface mount. That's kind of like that. This style is nice for me. I like that stuff. Or yeah, something like that. Right angle button, huh? It's just interesting how much I've had to flip back and forth of okay, I'll do it top, I'll put all this stuff on the top. No, I'll put it on the side. It's just interesting how the constraints get dictated. But it does seem like I am basically going back to what I had, which is that everything is mounted on the side. All right, so let's try to get one of these buttons. I feel like this. So the question for me is, if we look at the footprint, I feel like I probably want one that's a little bit longer. What the hell are pins 3 and 4 for? That's weird. But it doesn't have the pin numbers on here, so how am I supposed to know? Oh, wait, it does. So pins 1 and 2 are the ones that actually, and then these are just like no connects, I guess. It's just used for strength, probably. So then, but then we need to look at the data sheet to get the dimensions of this thing. Right, okay, so we have this 6.3, but then, oh wait, okay, wait, we have, oh my goodness. So which one are we doing? We're doing the 9. Okay, great, they don't have the 9. But it's clear that, wait, the height? Where's H? I don't even see H in here. Am I blind? All right, let's just use this. I'm down to use this thing. Okay, so we have the button now in the front. We're all now we have the barrel, we have the switch. We have the jack. The last thing is a potentiometer and the LED. All right, I'm gonna take a walk around the block and I'll come back in a moment. We'll do the LED and the potentiometer. Then we're finally ready to finish the schematic, assign our footprints, and maybe order this thing today. That's really the goal. I have like the rest of the day and we're gonna finish this thing. Another thing that I was thinking about actually is that like height map, like the simplest, if I really wanted to just go with something that works, that has surface mount parts so I can try out the hot plate and stuff like that, I really don't need to do any of this height matching because I would just leave the top of the PCB exposed. And I would just use a couple of like 4 standoffs in the mounting just to get it, raised a little bit so that there's no contacts touching whatever I've got it on. Oh, that's small. That's 0805, man. Do they have the like big ones, like surface mount, but with the big ones? These are all gonna be surface mount, right? Or can I get a Broadcom makes LEDs? What the hell? So these are probably all gonna be surface mount though, but like, lathe? What the hell? I mean, this is what we just had, but like, I just didn't see anything. Oh, package, SMD through hole. Yeah, stuff like that. Right. Make some food. Hmm. Hmm. I thought we saw last time that there were right angle. There were right angle LEDs. Oh my god. I can't type today. Dude, people hate on Thomas Edison because he was psycho, but Thomas Edison is actually awesome. Thomas Edison was crazy, dude. I love that stuff. This stuff is great. All right, cool. So let's finish this thing up, man. We gotta lock in the second. I'm gonna get some water though. I need some water so bad. Okay, all right, come on. Where's my pen? All right. So what are we gonna do about this LED though? I could have sworn that we had. Okay, I think that's what we're gonna do. We're just gonna use a standard LED. So when I look up, whoa. Oh, you know what? I think this is where we saw this stuff. Yeah, it wasn't on LCSC. But if I look up horizontal LED, that's not a thing. It needs to include. Is there a way to make it include horizontal? What if I in What category is this in? I'm just a little surprised. I feel like... Alright, well, in any case, let's just use the standard, man. But we are going to use the standard... Okay, what is, like, the most common... Oh, and this has to all get changed, but this is actually going to be out 1. If I change this, it doesn't change that one. That's great. Okay, so let's add our barrel. I wish I could see the 3D model. Those are just the same thing, different heights or something. Or no, I think one of these might be... No, I don't know. Did I never download a barrel jack? Oh, there, this one. So 3 is a don't connect. 1 is the tip. So this is 5 volts. Okay. Oh, we need a potentiometer, but we'll do the potentiometer. We're not even ready for the switch. The button we're not ready for. Okay, so let's do this thing, man. All right, so let's close all these. We'll find we found the LED in just, you know, the standard thing. I'm gonna go put my dishes away. All right, so let's do part 2. Part 2 I think is a little bit easier.
So in the last video, we used a 555 timer here to build this little clock circuit. And so we have our pulsing clock output on pin 3 of the 555 timer. And we can control the speed using this potentiometer. And so that's great, but there might be times when we want to manually control the clock. And we want to be able to just push a button each time we want the clock to advance or we want our computer to advance one clock tick. And so you might think, well, that's pretty easy. We just hook a button up. And so we have, this output here of the button is pulled to ground through this resistor normally. But then when we push the button, and if we stick that 0.1 microfarad capacitor in there, that's going to give us 0.1 seconds versus Q. And that's going to, and so you might hear this refer.
All right. Okay, so pin 2 is going to be, what is it? Shift L? No, it's Control L. Oh, okay. Oh, it goes the other way. Oh, wait. But this doesn't actually have the button. So wait, we need to now look through. Oh, this is actually annoying. I wonder if we can. Okay, if I just put this down and then I do this, and I do, oops, this, and then I do this, then I can just look. Because these should have the same name. So we are doing the right angle. Well, this is the one we're doing. Key TH. Okay. Wait, what? I thought it was control. Oh, it's not Control G, it's Control L. I think that's it. I think we did it. Now we just need to clean
to is a
up.
monostable mode of the 555 timer because it's called monostable because there's one state where it's stable, and then if you push this button, it goes into this other state where it's not stable, where it's going to eventually this capacitor charge and then it'll drop out of that state. Whereas the what we did in the last video with this is called an astable multivibrator or astable mode for 555 because it doesn't have a stable state. It's constantly altering between two states on and off. So you might hear those terms, monostable and astable. So take a look at that in action. I've hooked it up to the scope here, and I've also gone ahead and put that 2 microfarad capacitor in there again, just so we get that nice slow 2-second pulse there. So if we fire up the oscilloscope here, push the button, you can see the output goes immediately high, and you can watch the capacitor charge, and then boom, as soon as it hits that 3.3
Right.
volts. So let's see, 1, 2, 3.3, yeah, 3.3 volts, capacitor gets there, and boom, that discharge pin flips, and the capacitor just instantly discharges, and of course our output turns off then. And so you can see any bouncing that the switch is doing in here. It doesn't matter, our output's already high, we've got that latch that's latched at high, and then as long as the capacitor will discharge away, and then boom, turns off. So I've got that 0.1 microfarad capacitor back in there with our 1 meg resistor. I think that's what I'm going to go with. And just like before, we've got that the control voltage pin, which is pin 5 here, that we're not using, and that's just kind of tied into here. And again, the data sheet recommends putting a 0.01 microfarad capacitor between that and ground. So I'll go ahead and add that in there, and that's just for that noise reduction that we saw in the last video. So good practice, put it there. And then the other good practice is pin 4. Also not using that. That's a reset pin that kind of ties right into the reset of the SR latch. It's an inverted reset. So normally it should be at 5 volts, and then bringing it to 0 volts forces this to reset regardless of what's going on over here. Just kind of override things. So we'll tie that to 5 volts there just to prevent that from accidentally tripping or anything like that. And I think that'll do it. So now we've got our timer here. So we've got that, and we can adjust the speed. So we saw that in the last video and go really fast or really slow. And if we don't want to use that, we've got a manual clock pulse here. So now we just need to come up with some way to switch between the two of those, and we'll look at that in the next video. So in the last 2 videos, we used these 555 timers to build an astable circuit with the pulsing output, and a monostable circuit that's normally off, but when we push the button it turns on and it's debounced so that we get a single clean output when we push the button. So this we can use for our clock, and then we can also use for a manual pulse. Now what we need to do is figure out a way to switch between the two. And so you might think, well, we should use a switch. And I've got a pretty good switch here. This is a little push button switch.
We don't need to watch this. I've seen this so many times.
Examine how the switch normally works. What you'll see is set. But then when we first make contact over here, even if it bounces, doesn't matter. The first time we make contact over here, we reset the latch, and then the output turns off. And so we have this nice debouncing that we can use. So
what is U3? Where is U3? Oh. My button. Damn it. This one we don't do, but pin 5 we probably do.
Let's hook that up. Okay, here it is.
Pin 6 is grounded. Pin 7 is left untouched. This one still has a cap. Pin 2. Okay. Because if this is grounded, this is always going to be low. Okay, so we need now, actually, I don't know how this works, so let's just do this. So now we need to do the output logic though.
And so we have this nice debouncing that we can use. So let's hook that up. Okay, here it is. So we got our switch here, and the center pin is connected to ground, which is what we wanted here. And the other two pins, one is connected over here, you can see, to pin 2, and the other one's connected to pin 4. And so just like we've got here, so one's connected over here to pin 2, that's our trigger, and the other one's connected over here to pin 4. And on both of those I have pull-up resistors. So you can see on pin 2 and pin 4, I've got a
Oh shit.
resistor going to 5 volts. I didn't draw that over here, but you know. We want to make sure that these are normally getting 5 volts unless our switch is set. Pin 3, of course, is our output, so I just have that going to this LED for now with a current limiting, 220.
So we will want to, so we do want to do that.
ohm resistor over there. And then, you know, pin 6 is our threshold, so we have that just at ground. So this comparator is never going to be on. So we don't have this resetting this way. The only way we're resetting the latch is through our reset pin. So threshold is to ground, and then pin 7 is our discharge pin. No need to connect that. We're not discharging anything. There's no capacitor in here. We're just so we just leave that disconnected. And then pin 5, as usual, we have
Wait, why is that thing so flat? That's goofy.
our little 0.01 microfarad capacitor in there for, you know, for noise as recommended. So now what we've got is you push the button, the light comes on. Push the button again, the light turns off. So not very exciting, but it is fully debounced, and we're using the SR latch part of the 555 timer. And so with that, we've actually got the sort of 3 different modes that you can use the 555 timer in. We've got the astable mode, where it's not stable in either state. We've got the monostable mode, where it's got one stable state, which is off, and then when we push this, it goes to its other state, but then reverts back to the state that it's stable in. And then this is the bistable mode, where it has 2 stable states, and so it's either in this state or that state. And so now all we need is a bit of logic to combine all 3 of these into our final clock output, and we'll do that in the next video. In the last couple of videos, we built our 555 astable timer, which is putting out this oscillating clock pulse. And we built a monostable 555 timer circuit, which gives us a debounced push button switch. So we can push this and we get a nice clean debounced logic output here. And then we built our bistable circuit here, which also gives us a nice debounced stable output for our toggle switch. Now what we need to do is just combine these 3 signals here into a single clock output signal for our clock circuit. And what we want is we want to either output our oscillating signal or our manual signal, depending on which one we've selected over here. So I came up with a pretty simple circuit here that I think will do the trick. We've got our astable pulse input, which is this guy. We've got our select, which is the push button select. And then our manual pulse, of course, is the manual button that we can push there to get a manual pulse. And so what you
Whoa, these are pretty expensive.
of.
Yeah, I mean, this looks like a better... Was that NAND, though? I think that was NAND. Oh, this was AND, though. But that was a single AND. It's a single AND. This is presumably a quad AND, or quad NAND. Okay. Let's just do it. What the heck are we waiting for? I don't want this Nexperia one. I just want the legit one. 04, 08. Alright, so let's just get them. This library rules, dude. This library is so cool. Okay, so now we have our logic. Now we can just make the we can just make it, right? So, okay, so let's add all three of these. Can we add multiple at a time? No, of course not. Why would you want to be able to add multiple at the same time? That's crazy. Okay. Can I just move them out here? Okay, so the first one is the NOT gate. So okay, so first off, let's just get started with this one. Okay, so this 08 is the AND gate. So we want so this is going to be out. But I thought no, I think I just have a resistor on. Wait, I actually. Let me go get the board. Okay, so here is the board. We're just going to try to figure out, so these logic gates. So pin 3, okay. Wait, pin, where's 2? Let's just do it how we have it exactly here, just so that I'm like not weirded out by anything. So then, okay, so if I out 1 is going to pin 2. This is the 08. Pin 1 of this is hooked up to out 3. Okay, so we have our first AND gate. This AND goes to the OR gate. Okay, so this is going to go to... So let's actually... let's get the OR gate. So, first and foremost, so this AND gate goes to pin 1 of the OR gate. Okay, then the pin 4 of this one out 3 also goes to pin 1 of the NOT gate. Similarly, out 3 also goes to pin 1 of the OR gate. Wait. How do I delete all this? Wait a minute, hold on. Wait, this is the OR gate. Shit. Okay, that's probably right, actually. Pin 1 of the OR gate is going to the out, is AND 1, yes. But this thing... Okay, so we have it. It's just that and that. Okay, then the output, so pin 2 of the NOT gate is going to pin 4. So let's just... So NOT 1 goes to pin 4 of the AND gate. Okay. And then this is out 2. And then pin 6 is AND 2. And AND 2 Oh, no, no, no. Oh, wait. Oops. Oh, wait, actually, let's do this. So, what do we have left? We need to figure out the halt. Oh, yeah, this is the real output. Okay. So let's do this. My guess is that 1 and 2 are ground. 3 is the... Oh, I guess we don't get a picture of it. I don't think so, man. I don't think that's right. I think... Wait. We need to make sure that... Wait, we can close all these, I think. The logic ones are fine. Okay, it is right. I think that these are probably ground, and then 4 is probably. Dude, I don't think that's right at all. The same thing. What am I supposed to do here? I literally don't know how to read this thing. All right, so I think I'm right. I think that these are supposed to be grounded. That we're gonna wire these up. This is a no connect, and then this is real out. Wow, this ended up being a way bigger PCB than I thought. Maybe not. What are we missing though? We're missing something. I can't remember. What are we missing? Oh yeah, footprint assigning. Okay, so all of these are just going to be capacitor SMD. Was that it, or did I just... Ugh, God. Oh, 0805 hand solder. Wait, what? What? Oh, okay doesn't do what I want. Okay, now this RV1 thing... Oh, we never picked a potentiometer. We need to figure that out. Okay. All right, let's get a, I want it all side mounted. I just want the LEDs on top and then everything else side mounted. All right, we got a plan. We got a plan, man. So, I think we have pretty much everything though, right? That seems pretty good. I feel like this isn't the case though. If I clear this, like if I go to this, this is a 10K, but do they not have? That's 17. Oh wait, no. What is that though? Way to make that the smallest number ever, dude. Oh, you've got to be joking, dude. What is that? Come on, man. Oh, here we go. 10. Wait, we can do 10. So this thing is 15 then? Or no. Bo Chen. Bo Guo Cheng. Alright, so if this is 10, this is 7, this is 8. I think I'm just gonna go with this. If we can get this through our thing, I think I'm gonna just send it because it's like beautiful. Yeah, so that's good. So we just need to assign this footprint. Wait, what just happened? Bro, god damn it. So here we're gonna say apply. Okay. And then we're gonna actually take this and we're going to delete it. And we're going to insert the all right. So how are we going to do this? This is the hard part for me. So I think we want this 0.1 inches. And why do we want that? What was the problem with using metric for everything? Was that what was the problem with using metric for everything? Oh, it was that I couldn't place the components. Okay, I think we're just going to do this. We're going to do 1 millimeter. We're going to start right here. We're going to draw our board outline. So we're going to go to edge cuts. And we're going to draw a rectangle, right? And I think I want to make it long. I don't know. Something weird like that. Okay, so what do we need to do? We want to do this. We want to first grab this and have our... Okay, so this is clearly not enough. So we need to... make this like big. Let's make it big for right now, and then if we can get away with something better... Okay. Okay, so let's first grab this. I can't rotate it? Wait, when you're what? That makes no sense at all. See, I couldn't do that. I'm just allowed to do that. But I don't think I want to do that. I think I want to do that. That's fine for me. I'm okay with that. Wait, but don't actually okay, no, this is fine. So width 98, height 47. Can we change this thing? Or let's just go through it all. So the first set of stuff is going to be like this thing. Maybe we should use this. Because I feel like if I can just get a screwdriver in there. Let's get rid of the number of turns. Is that the one that I just had open? That's actually not so bad. That one? Ow, fuck. Because that's exactly what I have here, except it's the vertical versus the horizontal. Alright, let's put a pin in that. Let's do a lot of the rest of the stuff. Okay. So what do we need right now is the U1, right? Yeah, we can move this closer. So this, we kind of want to move these to the back, right? Or somewhere around here. Let me move this out of here. We'll figure that out later. Okay, so what do we need? We need I think what we should do is we should get C2. Where's C2? Why does it let me put it in there? That's weird. It lets me put it in there, but it doesn't let me... Why can't I... Okay, let's just do that. Okay, so we have this thing. Now we need R1. R2, C1. And we wanna also wire this thing up. So we just put this here. Or wait, we probably don't want to put this exactly here. I just don't know how you do this, man. This is so, you know. Why can't you rotate? Okay, we need to look that up. Whatever. I don't care. Wait, what layer is this on? What is FFab? Is there info about what that means? But that's a problem. The problem here is that the actual important bits. Actually, no, we can get around this. Wait, but what does discharge need to go to? All right, let me. Let's just start to place them without actually. Let's get rid of all the traces. Alright, if I just gave a rough idea of kind of what I thought was going to go on, it would be like approximately similar. What is this? This is the button? I would expect the button to go... I kind of want the button to go over here. Because then I can use my right hand. Wait. I'm not allowed to... No, it's allowed to go there. Oh, it's a pad keep out thing. Okay, fine. Whatever. This is my first go of it. We'll see how it goes. All the resistors. Okay, the logic. Why can't I grab these? It's just... G is the nice tool. Why don't you let me use the nice one? Okay, so the logic... I don't know. The logic can go here, but I don't really know where we want to put that. Alright, so it's clear that that we're not going to need... Wow, so we have... Okay, so wait. If we were to do this Eurorack style, we get 110 and we get 20. Oh, wow. Oh, and then you know what we forgot though? I need the mounting holes, so I can't actually put these... I can't put these here. Am I supposed to put them in the schematic too? I mean, that is crazy. Because then we, oh yeah, then we have to do that whole thing. Oh, that's right. Right, okay. Then we have, this is where I got stuck last time, is that when you place these, we need to actually, like, go in and figure it out. So, all right, let's keep going. So, I think though what we want to do is what needs to go here. Let me try to remember what this thing is gonna look like. We're gonna have the power jack. A switch. The I think I am gonna switch to that side mounted pot. Why doesn't it take me there? Oh my goodness, bro. Wait, but why did this one not go away? What is this? This is the button. Maybe we'll actually do this though. I like that. Then the input and output are all on one side. You plug it in. And then my button can be over here where I want it. The thing is, it's not like I don't know. I don't know. So what's up with this what's up with this thing? Oh wait. So what is the difference between G, which I can't rotate, and M, where I can rotate? That's random. And I'll probably make these... Oh, interesting. I'll probably make these a different color. You know, let's I don't even know how you're supposed to do this. This is totally crazy to me, man. Ground and what? Oh, this is the... Okay. This one's easy. Or we could even do this. Five volts in the button. Where's the button? But let's oh god. U4. We should actually switch U. This is really crazy, man. I don't know how people do this for real. Okay, this is between this discharge 2, so pin 7 on the second guy, yeah, and 5 volts. Ground and 2.6. Isn't there a way to like compactify some parts? What? Okay. What is this capacitor for again? This is, oh, this is nothing. Okay. What about this one? Oh, this is also... This is, okay, this is... It actually looks kind of good, nah? It actually looks kind of good. I mean, I don't know how to make the traces. And I kind of want to do the traces manually just for funsies. But dude, we're going to order this shit. It's going to be fun as hell. Wait, that doesn't look right. I think that's just a problem with the model. The button model. If I'm sinking and laughing, it's something sunken and I am. Do we want the decoupling right by the barrel jack, or do we want it somewhere else? Okay, this is the switch. I wonder about the clearances here. Maybe it went too ambitious for this first PCB. This has like gotten way out of hand. What is this? 5 volts in switch 2? Oh, okay. So this is, yeah. I could, oh, okay. Yeah. I feel like there's so many things wrong with this, though. Where does this need to go? Switch 2 and 5 volts. How do I like net select? How do I select? I'm sinking and laughing at something sunken, and I am. If I'm sinking. Okay. This is a capacitor? Okay. Which one is this one? I wish it said the part number on it. Oh, it does. Doesn't it? Okay. This is the 04. The 04... is the which one? This is the not. Then the 08 is the and the 32 is the or. Okay. So this is the not. Let's just try this. What is this one? This is the and. The and gets the most use, so it should probably be in the middle. Try to auto route this thing. See what's up. Okay, I'll be back in a sec. But this is what it looks like. We're gonna try to compactify this, I think. I'm gonna see if we can get it down in the size. How many vias are there? Wait, unrouted? I feel like that's not even... Oh yeah, see, it doesn't update until something happens. There's 16 vias. And then I think we want to do this thing, right, with the ground plane and everything. We're going to make ground planes on both sides. We're going to try that just cuz like that's what all the cool kids do. But we're nearing the point where I'm going to order this thing. And it seems like it's been 2 years to work up the courage to do this thing, which is kind of sad, but at least I'm getting to it, you know? We're finally going to get surface mount technology, baby. So sick. Why does it do this? What is that? I don't know why I wouldn't just... Isn't this a through hole? Oh, this is surface mount. That's why I need a via there. Right, so actually if we were to... Like, I just want to see what happens if I delete this and delete this, and I try to... It doesn't do anything because this pad is only on the... But for instance, this pad, it's also blue. Oh, God. Wait, why didn't it... Selection filter all... Oh, because vias are locked? My God. What? Y'all saw that? What the hell was that? I kind of don't like that the, Oh, nice. That's nice. But I can't constrain their distances, right? So I should be able to move... Oh, and it just destroys it? Come on, man. Is that the solder mask? Oh man. Okay, we're gonna do it all over again. Okay, so it's by the center. So okay, so what we're gonna do is we are gonna make this. Can I do math? Like if I do x is gonna be 70 minus 3.5. Okay, cool. And then we want to lock these, right? Can I take this thing and just lock it? Lock it, lock it, lock. Toggle lock. I just do L, right? Okay, so I just do L. Does that mean it's locked? Cool. Is there a way to just pull up? Oh, nice. Wait, move. Bro, come on. Is there a way to... So there's this move. Move exactly. Shift M, move exactly. Like tools, place. It would be under this. What is this? Positioning tools. Okay. So I need to do Shift P, this. That's so lame, dude. Oh, nice. Okay, so at least that comes up right next. So then we want to do 70 minus 3.5, 40 minus 3.5. All right, we're getting a move on. Now I do want to try this thing. So how do I like, because I want to basically move this so that I want to move this. So, oh, so it's all relative to pin 1. You have to move it relative. If I click on this, oh, I can move it relative to the pin 2 now. But it doesn't really. I don't know how people do this, but that seems okay to me. All right, so now I want to put in my what goes first? What is this? This is the pot. Not gonna be able to get that in there. That's okay. Put in the potentiometer. Put in the switch. Damn it. U1 is gonna get hooked up to the potentiometer. Let's give this some more room, I think. I don't know what the hell I'm doing, man. But let's just get this over here. What if we just put them up top? See, like, it would be so nice if I could just say that I want this line coincident with that line. I don't know how you do that, but I want to be able to do that. But instead I have to, like, fight this thing. Oh, that's so fucked. This whole software is broken, man. Okay. And now I want to be able to say, like, this is, like, how much spacing I want between these things. Like, what is this weird locking thing? What is that? I don't know what that is. What happens if I just do this? Isn't that all the parts? What happens if I just auto-read it? I don't think it'll be able to do it. I guess it did it with 33 vias. So we're gonna need to move everything around and give it a little bit more breathing room. Is there a way to move? Oh yeah. Is there a way to move these only in one direction? Because if I move these, if I want to move them locked. I just feel like the tools for positioning are like so... What is this? Is that a trace? Here, let's do this. We're gonna... Alright, let's do this how I would actually do this. We're gonna have the resistor right below it, okay? So let's get these, figure out what to do. Or we're gonna have them, let's say we're gonna have them to the left of it. So then if this position right here, this lock zone, why are you stealing my cursor? Okay. So from here to here. $7.1. All right, so let's say that we want... but it's so annoying because we can't... I think you have to go... to the footprint editor to like... Let's watch someone build a board. Can we watch someone do tracing and layouting? Has there been any chat? I'm curious. Let's mute this. My guess is someone said something. Vladimir Lenin said something. All right. Like I want to see someone do like a start to finish.
My brewery. Connect. Pets are here. Add a pet. 3 pets. 6. This one again. Position the 7 PCBs. Zones. We go to my update PCB from schematic. And here you see all the components. We first define the PCB outline. For that you use the edge cuts layer. Select edge cuts. Then we draw a rectangle. First just draw one. Press escape. Double click and then define the size. 40 mm long and 12.2 mm wide. Okay. Now we zoom to fit and we bring that rectangle to our components. And zoom again.
No.
Now let's rearrange all the components. Here you can set the snap grid. You can move them with the mouse. If you want to rotate, you can use this button, or you can press R. All components are placed. Now we add the tracks. Click here to add a track.
I don't know, man. All right, let's just do it dirty then. Everyone else seems to just do it dirty. Okay, which resistors do we need? So let's okay, so R3. Okay, so R3, R8, R9, and R10. That's for this one. Okay. Okay. R8. R9. And R10. Cool. Now, what do we need to do next? We want to get let's do this then. So we want R1, R2, and C1, and U8. U8 is this. So we want R1. Yeah, C1. R2. This capacitor maybe goes here. It's getting windy. Okay, so maybe a better thing would be, let's see, how do we want to do this? Let's get these guys. I think I actually want to do this. So we end up using this, but I think that I'm probably going to switch that because it's totally, KiCad doesn't know, but it's totally, you know, so then we can just use this side and a trace to there. Then this is the AND gate, presumably. Let's, So this is the 08. So the 08 is the AND gate. So that one needs to be pretty central, I feel like. And then the NOT gate, we only use 2 NOT gates also. So because they don't connect, can we just run it like this? No, but we can run it like that. Alright, so that's what we want to do then. But then this gate, maybe we want to put it by the let's see. I'm gonna keep track. I'm gonna keep moving them around and just see how well does the default auto router do. Like as we start to improve the layout. We're gonna do the routing myself, but I do want to just use this as a heuristic. Okay, so here we had, okay, so I'll just call this 5:08 p.m. This had 324 track segments, 20 vias. And then the number of nets should not change. Okay, so we're gonna go here, tracks, vias, delete. Okay. So now we're gonna start to clean up this mess and this mess. So what did we say? We need this is near the switch. So we want this one near the switch. So let's, I think we should do this. Oh, that doesn't work. We need to do this. Oops. Oh, it's tilde. Nice. Okay, that's good. That's gonna be good. I think that's okay, right? Where is this going? 5 volts. this goes to the buttons, so this one we want to put over here. Dude, the second time I did this, man, we got so much space. It's luxurious up in here. This is low-key starting to look like a PCB that I am not like offended by or embarrassed about. I feel like I like it. Oh, you know what? All right, we're gonna have to spend a lot of time working on the silk screen because I've been putting them in the center, but you don't actually want that when you're debugging because you want to be able to see what it is when it's already whatever. I don't think it's gonna be a really big problem from this because of this because I designed it, so. I'm not like too worried about that, but okay, so this is just the decoupling capacitor. So we want to put this oh. Actually, we have so much room here. Oh, you know what? Actually, though, I forgot. There's a crucial thing that's missing, and I'm wondering how we should handle this thing. How should we handle the halt signal? Low key, should I just tie halt to low? Or high? Because this isn't... What's the signal? So the 04 is the not. So if halt is high, this is low. So if you pull halt high, then it's halted. So I think I want to do this. It's a lot of space for the halt signal. A lot of space for the halt signal. I'm just wondering, like, how else should we do it? I was thinking we could use a dip switch, but like, the thing about a dip switch is if in the future I want to actually use the halt functionality, then it won't work. So I think I want to do this. I think I'm fine with this. It's just so big, you know? That's kind of the unfortunate part about that. Okay, cool. So I'm kind of okay with that though. One thing that I should wonder about is that 7 mils, what is the diameter of a standard M3 socket head? Okay. So we should be able to get in there. I wonder if I could go. Wait. It's so manual. The hell is this? These really can be right up to the border. It's amazing that people can do this. This looks worse. This looks way worse. I don't even think this is gonna work. It's too cramped. I guess not. The one thing I think I am gonna try to add maybe is like a pin header. Like it might be nice. Oh, actually, you know what though? I can just use these as my pin headers. So we have those as my test pins. I don't know what else I would possibly need to test, so. So I think we did it, right? Like, do I really need to go through and manually route? But you can't even select it. Alright? What? What is going on here? But I can't unlock it. How do I... Bruh. What are you doing? But it's so annoying. How do I unlock it? Tools. How do I unlock this thing? Oh, you know what I have to do? Oh, this is what I have to do. Okay. Locking, toggle lock. That's what I have to do. Locking, toggle lock. Oh, oops. Okay. So what I need to do is... We're at 55, right? I might try to move those up a little bit. Just because that almost certainly is going to collide. Should be careful for other things. Like this is going to be back. I think that that's actually going to be fine because at least we have that cutout there. But this one... Ugh, that's fantastic. I want to align them to... Oh, it's because I have the... Oh. Oh, jeez. Rule areas. Wait, can I lock? I want to lock this. There we go. Oh, wait, we didn't actually place these. So this is going to be 55 minus 3.5, and this is going to be 3.5. L. This is going to be 55 minus 3.5, 40 minus 3.5, L. I'm doing it entirely off of vibes and aesthetics at this point. Alright, let's try to see how the router does. 20 vias and in way less space and with the halt signal. Okay. That's pretty sick. I am wondering though. Okay, so we're gonna rerun it. Tracks, vias, all delete. All delete. Okay, we still need to do the silk screen. But I want to move this back a little bit. And I want to move this for a little bit. I'm going to try to... Because for some reason, even though this is like this... Maybe it's supposed to be like that. Alright, so let's... Maybe it's supposed to be like that. I'm going to have clearance in whatever box I put it in anyways. So what if we just undo the deletion? Okay. Okay, so now it's time for the silk screen, right? So we want to get rid of this. Paste. There should be no back paste, right? Okay, yeah, good. Okay, no back silk screen. I don't know what that is. Okay, so we're really just looking at... What is FFab? Footprint... What is footprint assembly? All right, it's not silkscreen. Okay. Oh, because it's locked? Silkscreen looks good now. Kind of worried about that. Maybe I'm gonna, you know what? I have tons of room. Why don't I just shift? Why don't I just shift? What is this? Let's see if we can still route it with the same level of quality. Now I'm gonna put a decal here. Let's put something cool. All right, how do I make fun decal art? And let's think about what I want to make. What do I want to make? What am I writing on right now? We want to write on the silk screen. It's a Bezier curve. Oh, I know what I'm gonna do. How do I do? Wait, how do I do it? KiCad. That's so cool. Oh my god, that's so cool. Is that what it looks like for real, bro? That's the coolest thing ever, man. Whoa. That's amazing, dude. Can I not import a Dude, that's so stupid. Wait, but is this gonna be on the silk screen? Can I group this? Okay, so I don't know how to get that onto the silk screen. Okay. But if can I hide a part actually? Is it possible to hide this thing? Okay, there is a hole in the board. Yeah, I was worried about that. This thing looks pretty nice. I just gotta get some artwork, man. In the footprint editor, use file, import graphics, load it. Okay. Also, is it actually an SVG? Okay, it is an SVG. Oh, fuck yeah. Okay, so now what do I do? Go to the footprint editor. What did it say to do? File, import. Why can't I do it? Why is it just white? The hell? The hell? Bro, why did it do that? Okay, anyways, let's just try it. Oh, fuck yeah. I should be able to just delete this, right? Oh, I need to save it though. Oh, I need to. Oh, that's so lame. I should have just saved it to something random. Oh, there is art. What? Why doesn't it have it? Oh, because it was untitled. We need to make it like... But I don't think it's gonna work because it's like... It's too thin. What's the thinnest it is? It's too thin. Make some popcorn. We're gonna finish this, man. So there is one more thing, which kind of like this thing. I don't know why I like this thing. Bezier curves are just generally beautiful. All right. But we need to do this. How do we do this again? It's this thing. And then I just draw. Wait, what? Draw filled zones. And then I draw a rectangle, right? I don't think that. Okay. What? What? This software is so annoying. Hello? How do you actually do it? This software sucks. How do you end it? Am I crazy for thinking that this is how you're supposed to end it? Bruh. Wait, what? What if I just do one of them? Does it work then? Yeah, that was weird.
Hello, my name is Cody Rogers, and today I'm going to be showing you how to add a ground plane in KiCad 6. So, first, we go to our layers here, and I always select the layer I want, which is the back copper layer. So now it's selected there. And now I go to this button here that says Add a Filled Zone. Press it. And then you click where you want to start drawing your thing, your ground plane, and you click. And then you have to select the net, which I want to use as ground, so I select GND. I press OK, and now you draw it by just extending these lines and clicking where you want like a corner to be. Okay, now that the ground plane is drawn, I will press B to fill all the zones. There we go. And now you can see all of those on.
Can't I just do this too? There we go. Cool. Can we hide it? I wonder if we can hide it. He actually uses 2 decoupling capacitors. Okay, I think I'm gonna log off and try to order this thing. I don't know, is there anything I'm missing? I have no idea. Oh. Oh, okay. It does the fill for me? Is there another one to, how do I